Hello, everyone. Thank you so much for joining us today. We appreciate your participation, and I hope you all are doing well. I'm Sonika Shivani, and I'm here with my team to talk about a project that we have been working on since last summer, which is customer segmentation for a company called TCS World Travel. Um, and we respect the confidentiality of our client, and so we have censored all the confidential information in this presentation. Firstly, we would like to thank the Center of Business Analytics, UW Tacoma, and Dr. Huluk Demikran, Director of CBA, and Dr. Michael Helser, Manager of Operations and Programs, for their support throughout the project. To talk a little bit about the team, I'm the marketing analyst with an MBA background, and Tanuj Mehta is our software engineer with a computer science background. Junjun Mo is our business strategist with accounting and economics background, and Rathana San is a project manager with experience in business analysis. In this presentation, we will be looking at the project plan, different types of analysis that we performed, and the factors for success, followed by a proposed technology plan for our client. So the main goal of this project was to segment TCS's customers based on the available data, and also to build predictive models for TCS to be able to measure the next best action, and additionally also to provide customer insights for them to make data-driven business decisions. The team divided the project into 4 different phases. For business understanding, for descriptive and diagnostic analysis, for predictive analysis, followed by cognitive analysis and deployment. Now, to talk about phase 1, we performed PESTEL, Porter's 5 forces, and SWOT analysis to get an in-depth understanding of luxury travel market and industry, and also to study the influence of social, political, technological, and economical factors on TCS World Travel's business. Our team designed this high-level data architecture plan for the ease of the analysis. First, we were given all of the customer data sets in the form of Excel sheets, which we then uploaded into Azure SQL Server, and then connected to different analytical platforms like Tableau, Azure Machine Learning Studio, and Python to work on our predictive models. Addition to the platforms that I just spoke about, the team also used Microsoft Cognitive Services to create a bot to analyze popular destinations. And we also used Power BI to visualize data and perform further analysis. I shall now pass this on to Rathana, who will walk us through the phase 2.
Thank you, Sonika. So for our phase 2 descriptive and diagnostic analysis, we built 2 predictive models. The first model was based on data or interest data from Wealth Engine. So here we have a Tableau dashboard that was connected to our Azure SQL Server. As Sonika mentioned, all the data has been masked for client confidentiality. So in the first dashboard on the top left, we have global customer size. So each dot represents a different country and their customer origin and size relative to that. So it'd be count, the larger count would be the larger size. In the top right, we have a more macro level view of a customer base within the US. Each bar represents a different state and their total count within the US of customers. The bottom left, we have gender demographics by age. Each bar in the graph represents a different age group and the breakdown of female and male customers. And in the bottom right, we have age distribution by net worth. So each of the bubbles represents an age group, and the specific net worth associated with that. And that's also size based. So the larger the age group within that net worth, the larger the bubble. So here's the second dashboard that we built with the client. The top dashboard here represents popular products by net worth. So TCS had product A, B, C, and D, and their net worths were listed on the left there. As you can see, they've all been masked. So this is a heat map. So the darker the color within the box, for example, product A with $2 signs, that is the highest concentration of customer count within the distribution of all their customers. And in the bottom here, the bottom dashboard, popular products by age of customer, we have product A, B, C, and D. Each bar represents the total customer count within the group, and each color within the bar graph represents a different age group. So moving on, phase 3 predictive analysis. So here we built a clustering model for the market segment, or to market segment the customers based on their interest features that we received from the Wealth Engine data set. So in our data set, we have interest features that vary from health and wellness to yoga to golf, etc. And once we have these clusters built, it helps us design the itinerary based on our customer interests. So here we have an elbow graph. So to identify how many clusters can be created within the data set, using the elbow graph, we use the statistical cost, which is the variance within and between the clusters. So based on the minimum within and between variance, we can identify clusters. So in this graph, we have 1 through 6, and these represent different clusters of customers. And so we selected the top 3, 1, 2, 3, for identifying the similarity between the people to build these clusters. So let me explain the clustering model with further details using this graph here. So here this graph was based on the interest of Safari. So if we choose Safari as the variable to be predicted, 0 is the count of customers who didn't vote for Safari, and 1 is the count of customers who voted Safari as their interest, which we can see is very low compared to the former. And individuals under 0 and 1 were further grouped into clusters 0, 1, and 2 based on their similar interests. This will help us to optimize marketing content and sales strategies accordingly. So this is an output in an Excel sheet where we can see all 21K records that have been categorized into clusters of 0, 1, and 2. This is, again, a proof of concept for interest-based marketing. Once we get the accurate data, this model can be used as a working model to pick destinations and activities based on customer interest. I shall now pass it on to Junjun, who will walk us through our second predictive model.
So thank you so much, Rutana. Before I start explaining our machine learning model, I would like to explain why we created this model from the business aspect. So our team focused on how to optimize marketing campaigns based on the average customer return time for different segments. As we all know, customers' profile, like their age, their gender, interest, are very important to learn their purchasing behaviors. So we created the model to learn the relations between the loyalty customers and the customer profiles. We predict and identify the customer profile segments by using machine learning models. Let's move to the model itself. We built this logistic model through Azure Machine Learning Studio. We created several variables for the model based on the 4 data sets. The first is the age group, book date difference, and also the return customers. Then we split the data into 75% of training data and 25% of testing data. So we decided to use the multi-class logistic regression to train our model which is assumed as a linear regression to identify the correlations between each variables. So Azure Machine Learning Studio is very easy and nice to work with because it automatically differentiates the categorical and the numerical data and also analyzes accordingly for the regression demands. So to better understand how the model performed, we evaluated. As you can see here from our output, the overall accuracy is over 64%, which is pretty good. That means over 64% of our prediction is accurate based on the current model and the current data. So the precision and record number are the same at roughly 64% as well, which is really good. And this same output here means they are equally distributed based on the current model we have. So the propensity model here performed very well actually, and it would be used to identify the current and potential return customers for marketing strategies. Then in phase 4, we have working on cognitive analysis on identifying top travel destinations. So here you can say our group created the sample and high-level word cloud to analyze the top global vacation destinations. We put the most popular destinations in the US and the Indian from the Google search and generate this word cloud, as you can see here. So the current word cloud is based on the country level. And the advantage of this analysis is it can be extended to the city level as well, which would provide more popular destinations, and then it can help our client to build their content strategy and also the new product offerings in the future. Also, the cognitive analysis could be extended further based on more countries and more cities data from the different data sources like Google, Facebook, Instagram, or any other data sources. Now I will go ahead and pass on to Tanush. He will introduce the factor for success and the technology plan.
Thank you, JJ. So the factors for success for any of the statistical model is to get better results are data consistency, data accuracy, no or little missing data. Looking at our data set, we can say the model would have generated a better results in case the data has been consistently and accurately recorded in the source system. Let's looking into the proposed technological solution that we gave to our client to upgrade the original analytical platform using the AWS serverless technologies. So we have, the core of this whole serverless technology is the AWS Glue application or service, which is used to build an application to connect to the on-prem system or to the SaaS platforms like marketing platform, accounting platform. And the data would be consumed and transformed, and the outcome would be pushed into the S3 bucket. This S3 bucket, the data would be encrypted over here for further descriptive and predictive analysis. To see the outcome of that whole business KPIs and outcome of the model, we use a visualization service called QuickSight, which runs on top of S3, and where we can build all our dashboards or reports. For the user to see all the dashboard and reports, they will be connecting through the private APIs or through using a JDBC or DBC connectivity using a virtual private network. And to make sure the security is totally paramount for the client, we also suggested to use a multi-factor authentication so the user can, right users should be able to connect to the AWS platform. So this is a whole architecture that we have proposed to our client. The value addition of our project here are the descriptive analysis provided using a Tableau has given a very deep insight about their customer base to our client. And secondly, the proof of concept models that we build can be operationalized to optimize the campaigns and target the right audience with the right product. Finally, we reached at the end of the presentation. Thank you for your support and looking forward to see everyone in the poster session. Good.